Hi everyone, a very good morning to all. Now we are going to study the question number 85, that is binding energy per nucleon or simply binding energy. Now the very first thing is what is composition of nuclei. When you consider the nuclei, so the general representation is like ZXA, where Z is number of protons or electrons also. But we are talking about nucleus, so protons. And A minus Z is number of neutrons. So every nucleus is made up of protons and neutrons. So total number is called A, that is mass number. A is called mass number. Now there are number of protons and neutrons all together combined to form a nucleus. Now the very first thing what we have to understand is what is mass defect. So mass defect means when you consider the total mass of the constituents of the nucleus like Z protons plus A minus Z number of neutrons. If you calculate the total mass should be, that is actually more than the actual mass. That means after formation there is a loss of mass, that we call it as mass defect. And according to Einstein mass energy relation, it says that every mass is equivalent to energy of E equal to mc square. So that every mass defect also equal to some energy, that is delta mc square. This is called binding energy. The energy required to break the atom into its constituents, or the energy released when all the nucleons combine to form a binding energy, that we call it as binding energy. So the binding energy is nothing but the energy equivalent to the mass loss or mass defect after formation of atom, some number of protons and neutrons. That is what the binding energy. And here comes the binding energy per nucleon. That is, this is the binding energy for all the nucleons. And if they are asking binding energy per one nucleon, then you have to divide with the mass number. And EBN is maximum for 56 ferrous. So for mass number 56, the binding energy is maximum. Approximately that EBN is 8.75 mega electron volt. So that is the most stable nuclide compared to all the other. Now, sometimes they will ask like a question like what is the binding energy of a nucleus? So that you have to take delta E equal to delta M C square, or they may give binding energy per nucleon. Then if they give, then binding energy will become EBN times A. And sometimes they will give in case of nuclear reaction. If there is a reaction is there, then you have to find total binding energy of products and total binding energy of reactants, and then you have to subtract. Like that also they can ask sometimes questions. Like we'll see the examples based on this, so that you will understand what kind of questions will be asked. Like the very first question is, Avogadro number is 6 into 10 power 23. Then the number of protons, neutrons and electrons in 14 gram of 6C14 are respectively. See, 1 mole means 6 into 10 power 23 atoms. Now, 14 gram of 6C14. Now, 14 grams of 6C14 means number of moles is 14 by 14. That is 1 mole. So that means how many number of atoms will be there? So number of atoms are 6 into 10 power 23. Now they are asking protons. In one atom, protons means equal to Z. Z means 6. So for these many number of atoms means for n atoms, it will become like 6 into 10 power 23. So that's 36 into 10 power 23. Now equal number of electrons also will be there. But neutrons means, when you consider neutrons, 14, one atom 14 are there. So 14 into 6 into 10 power 23. So then it will become, this is total number of nucleons. This is 84 into 10 power 23. Therefore, number of neutrons means A minus Z. This is not neutrons, this is total nucleons. So total nucleons, this means 84 into 10 power 23. So number of neutrons means A minus Z. So 84 minus 36 means 48. So like that, you need to understand how many number of protons or neutrons will be there in a particular atom or in particular amount of atom. Now the next one simple question, similar question I think. 11 sodium 23. The number of protons means Z. Z equal to 11 protons or electrons. And neutrons means A minus Z. A minus Z means 23 minus 11, that is 12. So 11 protons, 12 neutrons and 11 electrons. Now if the binding energy of deuterium is 2.23 mega electron volt, the mass defective given in AMU. See, 1 AMU is approximately equal to 938 or 935 mega electron volt. Now the given binding energy is 2.23 mega electron volt. So that delta E equal to delta MC square. Now delta M equal to delta E by C square. So you can calculate and you can find it. Or else according to 1 AMU thing, see, 938 mega electron volt is for 1 AMU and the given is 2.23 mega electron volt is for how much? Then the mass will become 2.23 by 938. So if you calculate, you will get the answer. Or else you have to substitute delta E by C square. Delta E you have to substitute in joules, C value you have to substitute, then you will get delta M in terms of kg. But they are asking in terms of AMU so that you can do it directly in this manner. Now find the binding energy of an alpha particle from the following data. Alpha particle means 2 helium-4. So that delta M equal to 2 protons are there plus 4 minus 2 neutrons are there minus M. MP given, Mn given, M is given. So capital M is they have given as 4.001265 AMU. Now what you have to do is find delta M in AMU. And they have given 1 AMU energy is 931.5 mega electron volt. Therefore, delta E will become delta M into 931.5 mega electron volt. So that always delta M you find in AMU and multiply with 935. Or if they mention any value like this, then you substitute that value. Then you will get the binding energy. Now, the binding energy of 17 chlorine 35 nucleus is 298 mega electron volt. Find its atomic mass. Now, binding energy equal to delta mc square. Binding energy is now 298 mega electron volt. Now, delta m directly you take in terms of AMU. So, how much it will become? 17 into 1.00866 minus 35 minus 17 means 18 times 1.00. Sorry, this is proton, no? So 7277 will come here. Here it will come 866. This is number of protons minus capital M. So this you will get in terms of AMU. Now 1 AMU means this much answer. So how much AMU will become? Or else you do one thing in a simple manner. So you just take delta M directly first. So delta M how much? 17 MP minus 18 Mn plus minus M. This is the delta M. In terms of AMU you take. Now 1 AMU means 931.5 mega electron volt. Then for the given delta M, what is that? 298 mega electron volt. Then cross multiply it. Then you will get the direct solution. So no need to find the C square value and all. So if you cross multiply delta M directly you will get in terms of AMU. So that if you substitute MP, Mn values, then you can calculate capital M value. This way you can solve it. Now similar questions I have given as an assignment. So please just try to solve it. And here you can see the questions I have given based on the same thing in NCERT also. So 1, 2, 3, 4, 5, 6, 7, 8. So a lot of questions are there. So you can understand simple topic, simple formula. So you have to understand and you have to do it carefully. So thank you all of you. Just practice these questions. We'll continue in the next session with next question.